Our last topic, dealing with geologic history of life on the planet Earth, is some of the major theories about the biggest question. We know life, and we see the different theories of how it's shown through time and how it's changed and things like that, but the biggest question that's always asked is, well, where did the first one come from? Or how do we get to those theories? Or how do we talk about those kind of theories? We've had different explanations. I'm going to give you the scientific explanation, because there are other theories involving things like religion and so forth. And which one's right? Well, that's for your decision to make, but I'm going to give you the scientific theory, how it should be talked about from a scientific standpoint and all the evidence that we've used. One of the first ones. People for a long time, especially in ancient Greece, had some theories that maybe today we would look at and laugh at, but people were trying to explain things and they didn't understand or have the knowledge from the standpoint of the evidence that we have today, so they were trying to figure things out as they went along. Did everybody in these time periods believe this theory? No, but there were people who did, and it clearly shows up in Greek mythology and things like that. The first one is spontaneous generation. It's the concept that you have inanimate object that turns into a living creature. Think about Greek myth, you talk about all kinds of things like statues coming to life, and usually things like the god Zeus will give a gift and cause a statue to come to life, or he'll turn a person to a statue, or they'll do all kinds of things. They'll make things rise up out of the dust. They'll turn them into soldiers and things like that. There's all kinds of stories about that occurring inside of Greek mythology and Roman mythology and a lot of the other mythologies. So in the scientific standpoint, people may have looked at it and said, well, that's stupid. It doesn't make sense. Because we can see that things happen. It took people to come up with an experiment, sometimes even a simple experiment, just to finally say, you know what, I'm going to show scientifically that that doesn't make sense. So Francesco Redi is a scientist, an Italian scientist. He comes up with an experiment, very simple one, but still elegant in the way he did it, in order to prove, this theory doesn't make sense. In 1668 is when he comes up with this theory to disprove the overall concept, so people can't keep saying, well, maybe it's spontaneous generation, things just show up. Remember, this is a time period when we're first looking at cells and things, people are trying to explain things like that. He does the meat in a jar experiment. And as the name implies, he puts meat in jars. Because the theory would be, if you have a piece of meat, eventually over time, if you leave the meat out, it's going to develop maggots. Well, spontaneous generation says the maggots come from the meat just turns into maggots. Today we know that's not true. We know that maggots are larval forms of flies, the baby versions of flies. So he wanted to prove that's what happens. So what he did was a little simple experiment. 2 jars. Control group, open, piece of meat. And as you would think would happen over time, as flies got on there, you got larvae in there. People spontaneous generation said, well, see spontaneous generation. Other ones, he put pieces of like cheesecloth on it. Little simple cotton cloth. Air gets in, so there was no version that air wasn't playing a role in spontaneous generation. But the flies couldn't get to it. So what happened? No maggots in it. So he was able to show, you know what? That doesn't happen. This is why it doesn't work. But people said, you know what? All these little microorganisms, I look in a microscope, I see all these creatures everywhere. There's no way they could just magically come from other creatures. They must come from the earth itself. The soil turns into little microbes under the microscope. So for a while, people still believed that theory. It took another scientist to come along and disprove it once and for all. That man, famously, was a man by the name of Louis Pasteur. You know him probably from pasteurized milk, because he invented a process in order to kill off microorganisms in a fluid by heating it. So in the mid-1800s, he decided to finally destroy the theory that microorganisms can come from inanimate objects. When he does it, he shows biogenesis by doing this. He takes a flask, he boils it, kills off all the microorganisms. He then puts a little bit of liquid down here. Now, stuff should be able to pass through it. If this was basically a normal situation where spontaneous generation occurred, inside that flask, you should grow microorganisms no matter what. Once you kill off stuff there, it should turn into microorganisms. But what happened was, as long as you left it like this, nothing, because it was blocked, the air was not getting through, nothing was causing microorganisms to get in there. If you tilted it, all of a sudden, it grew microorganisms. So that became a problem. He was able to show that it was life coming from life, biogenesis. But that also then led to that big argument and question, where does that life come from? We can see life coming from life, because it's what we see in nature normally. So there are a lot of modern ideas about where does that life come from, the very first life. It's always going to be an argument. People have, you really can't go back in time and see, so we always going to have to argue and debate over what we think using scientific rational explanations. One of the first things that scientists theorized, what was the early Earth like? Looking at rocks, breaking them apart, finding gases that are trapped in them, looking at other planets in our solar system, we want to say, what would the early atmosphere be like? It would have had not very much free oxygen. There's oxygen, but it's trapped in compounds. If you go to most of the planets in our solar system, same concept. There isn't very much oxygen just floating around freely. Lots of water vapor, pretty common. Carbon dioxide. Go to most of the planets in our solar system, a lot of them have carbon dioxide. Nitrogen, still very common. These are all still common in our atmosphere. Take away that first one, these are still common in the atmosphere. Methane, also still common. All these are things we find in other planets very commonly. Now, the thing is, you look at this, there's oxygen, there's hydrogen and oxygen, carbon and oxygen, nitrogen, and carbon and hydrogen. If you think about those things, those are the four elements of life, CHO and N. So they have the basic building blocks right there in this grouping. So then the theory started focusing on, well, how do you get cells from that? And a lot of people came up with how do you go through molecules. Well, you can put them together in chemical reactions. There were people who argued about different ways of doing that, how it can get to this concept. With the theories of cells, if you get those molecules, you could eventually lead to molecules working with each other. You have things like prions, which are proteins, which are just molecules, but they act like living creatures, even though they're not, technically by our rules. But they infect things, they take things over, and they're just weird proteins. So it's not a stretch to think you can go from a prion or weird protein to a living creature. So theories of cells is, there are a lot of theories. Every scientist who studies this has their own version of how they think about it because there's different evidences that show different ways it could work. The fact that you could have very simplistic, basically membranes or layers of fat that form around other types of molecules like proteins or DNA and thus form a first cell. But once we have cells, then you know it goes from, how do you go from the simple cells to complex cells? And the biggest thing is we think the first types of cells we find fossils of are things called archaebacteria. They're very primitive. They're still around today. They're very odd. They can do things like live without oxygen, eat methane, survive in extreme temperatures. They can even live in the vacuum of space. So they're kind of these hardy, weird creatures. And then we think eukaryotic cells came from the endosymbiotic theory, one we've already discussed, where you took small little single cells that were swallowed up by bigger single cells, and thus those little cells became basically like little friends inside of the bigger cell, and they started working together and became reliant on each other, just like the bacteria living inside of your intestines are relying on you and you're relying on them. They have to work together. So it kind of comes with that theory. Again, there's always going to be debate on these things. So we have to sort of look at the different values, and we're going to keep finding new evidence and keep coming up with new theories all the time. So it's one of those things that's always going to be debated and talked about for a long time. And that is the end of our unit.